Hi everybody, my name is Gina Malcziewski with the Outreach Group at the Midland section of the American Chemical Society. I'm here today with my intrepid cameraman Dave Stickles, and you see I'm wearing a mask. We encourage everyone in this age of COVID to wear a mask. Be kind to everyone else and to yourself by wearing a mask. But because Dave and I are a safe distance apart, I'm going to remove my mask so you can hear me a little bit as I explain today's experiment. You see also that I'm wearing my safety glasses. This is good behavior for a scientist in the laboratory always, even if you are using non-hazardous materials as we are today. It's a very good habit to get into, and anytime you splash anything in your eyes, even if it's plain water, can have a very unpleasant feeling. So today we are doing an experiment called the yellow and blue experiment. So you know that color is going to figure importantly in what we're doing. We every day in our lives we use and make a lot of solutions based on water. And a true solution is one that is made of water and another chemical where those two combine in such a way that the resulting mixture is what we call homogeneous. It looks very uniform. If you look at it, you may not be able to tell there's anything in there but water. So if you think of a mixture of sugar and water, what happens at the beginning is that you can distinguish sugar crystals and the water. But over time, the water interacts with the crystals, breaks those particles down into smaller particles and eventually into individual sugar molecules, which then interact directly with water molecules such that you get that intermixing and you end up with a uniform mixture. Now the sugar appears to have disappeared, but it is there. It hasn't lost its chemical identity in any way, shape, or form, and you could taste it and tell that there's sugar there. But the solution itself gives the appearance of being just a single chemical. So the mixtures that we're going to be using for our testing today are all like that, homogeneous solutions. But before we get started, I want to make sure that we're clear on a couple of other concepts. We mentioned how important color is to this experiment. We're going to be mixing yellow and blue, and we're going to make another color, which is green. As you know from mixing yellow and blue crayons together, when you do mix those colors together, you get the color green. Now we want to talk a little bit about this, and this is really physics, not so much chemistry at this point. You see I have a beaker of water that's been colored with some blue food coloring and a vial of water that's been colored with some yellow food coloring. Now the yellow appears yellow because the yellow frequency of light is hitting our eyes. We perceive yellow because it's being reflected from these materials. The blue water similarly is reflecting blue light. That means that all other wavelengths of light are being absorbed by these materials. So we can't see those, but we see the blue and the yellow. So if I put this vial, stand it up in this beaker, we now see there is yellow water still in the vial above the level of the blue water in the beaker. But when we look below, we actually see, or what appears to be, green water in the vial that's inside the blue water. Now this is because we have a mixture of the blue reflected light from the water and the yellow reflected light from the vial, and blue and yellow together make green. But in this case, we have a mixture that is can be separated very easily from one another. If we take this vial out, we still have yellow water and blue water. So these have not been allowed to mix in any way. The mixture occurs in our eyes with the mixture of the wavelengths of light and the reflection that is received by our eyes. When we are doing our experiment today, it's going to be chemistry. We're going to be physically mixing solutions, molecules of two different materials together. So when those physically combine, they are going to be very difficult then to separate out again after they mix. Another concept I want to talk about very quickly here is the mixing of water with other substances. We have talked about making homogeneous mixtures or uniform mixtures from materials with water, but there are also cases where some materials do not combine with water. One of those may be something that we encounter frequently in the kitchen. Here we have some blue water again, and now I have some yellow oil. Maybe from your past experience, you might be able to predict what's going to happen when I add this yellow oil to the blue water. Now, if I pour this in, you're going to see initially that the oil appears to go down, but over time, as things settle out, you see that there is a layer of yellow on top of the blue. So yellow and blue, under these circumstances, does not make green. And we will always see the oil layer rest on top of the blue layer, no matter the order in which we add the water and the oil. Because oil is less dense than water, oil always floats on water. So this is a little density experiment here, and I want you to keep this in mind, and we're going to recall this when we do one of our solutions in our blue and yellow mixtures. So moving along, we're going to take advantage of a couple of different resources here, and anyone who wants to do this experiment, especially teachers, will be able to access these resources from us by direct contact or through links at the end of this video. We're also going to show you close-ups of what they look like. So here we have a piece of paper inside a sheet protector to make it waterproof. So we're going to be adding our droplets of materials to the top of this sheet protector, and we're going to look at the mixtures, and then we can wipe everything off and start all over again. That's the advantage of that. Here we have a little bit of information about how our mixtures are made. And again, we are going to share that with anyone who would like to do these. This experiment is very easy to do at home. About the only thing you might need to get would be, if you do have a first aid kit that has rubbing alcohol in it, is you might need to purchase something like these water bottles or some other small container that allows you maybe just a regular little glass with a little eyedropper would allow you to drop droplets onto the paper. So you see the first thing we have here, moving left to right, is yellow water and blue water that we're going to try to mix together. This is like our control experiment. These two materials are exactly the same except for the food coloring that's in them. So whenever I drop a droplet from my water, from a bottle, I am going to invert the bottle vertically and try to squeeze directly toward the bottom of the top circle, and then the bottom material is going to be dropped at the top of the second circle. I'm going to demonstrate this right now. This just minimizes the distance between the two droplets, making it easier for us to get them to come together. So we're going to keep this vertical, 5 drops. 1, 2, 3, 4, 5. Okay, note the shape of the droplet that we have there. And now we're going to start with our known yellow water. So we're going to do the same thing. We're going to try to get it near the top of this second circle. 1, 2, 3, 4, 5. Notice the shape of that droplet. Now, in order to encourage our two droplets to come together, we're going to use toothpicks. Flat toothpicks might work a little bit better, but pointed ones work just fine. Just be careful of safety aspects. And we're going to use the toothpick always to move the blue water into the bottom material. And we're going to do this. We're not actually going to force the two together. We're just going to get them near enough to be able to go on their own and mix together. And we're going to watch what happens when they mix. So we're going to move this down a little bit, get it closer and closer. There we go. So there you see we have blue, we have green here in this area between the yellow and the blue, but we do still see some yellow. Now, molecules are always moving in solution and in the air, and so it is going to take some time, depending on the temperature of our droplets, to see the total combination of yellow and blue to make green, but it will occur over time. And especially if our solutions are cold to start with, you could do this as an experiment. That will take a little longer because the molecules are moving more slowly when they are cold. So our next experiment is going to be testing blue water. We're always going to be testing blue water with salt water. So 5 drops, 1, 2, 3, 4, 5, with 5 drops of salt water. Okay, 1, 2, 3, 4, 5. Okay. Now make sure you have a clean tip. You can use the same toothpick, but just use the other side of it. You can usually tell if the toothpick is dirty because one end might look blue from the blue water. So we're going to mix these together. Look very carefully at this as these join, and then we're going to do something else to get an even better look. Okay, notice something interesting about the way that came together. You can see sort of a yellow rim around that joined droplet and some green followed by blue at the very top. Now if you could get down right at the level of the plastic, you might be able to see that the yellow is the layer closest to the plastic and the green and the blue are above it. In order to visualize that a little bit better, we're going to take that experiment to a test tube, give it a little bit more three-dimensional quality. So Dave is going to hold the test tube, and I'm going to use 10 drops of water now, and notice that I'm adding the water first and the salt second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're going to wait for that to get to the bottom. And then we're going to add the salt water along the side again to make the mixing as gentle as possible. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He's going to make that vertical now, and we're going to put it against some white paper and see if you can see at the bottom. Hopefully you're seeing more yellow at the bottom than a green layer and then the more blue at the top. This shows that the salt goes down further or stays down at the bottom. So the salt water is denser than the blue water. Okay? So the next thing we're going to do is our pair is going to be water and detergent. So keep your eye on this, especially the shapes of the water droplets involved. Okay, so 1, 2, 3, 4, 5, and then detergent. Detergent is made from hand soap or from dish detergent. I've started with orange here. You want to start with a color that's going to, when it's diluted and maybe with a little bit of food coloring, looks mostly yellow so that it looks like all of our other solutions for reasons I'll share with you in just a moment. So this works pretty well. If you have yellow to start with, that's obviously optimal. You can use hand soap, which may be easier to find in lighter colors, but hand soap does have a lot of extra stuff in it besides just the soap and the water. It usually has perfume and the pigment and maybe something to help your hands stay soft. So all that may change your results. So here we have detergent. I'm going to do 5 drops. 1, 2, 3, 4, 5. Now notice that drop doesn't appear like the drop above it. So obviously there's something going on with the chemistry of this droplet versus the other. So let's try to get them together. Ooh, that happens very fast. And again, we have a yellow ring maybe around the bottom part where the detergent is, but it does not go up to the top part. We still have blue up there. And that mixture has happened very quickly. So we have a couple of interesting observations with that one. The next one is water and alcohol. So I'm going to try again. Oh yes, our alcohol solution is made directly with this 70% isopropyl alcohol that you get from the drugstore. Should be in everybody's first aid kit. It is antiseptic, so it kills germs. And what we're going to do is just take this directly and add drops of yellow food coloring to it, and that's going to be our alcohol solution. Okay, so we're going to start with water again here. 1, 2, 3, 4, 5. We're going to do our alcohol. 1, 2, 3, 4, 5. Again, notice the shape of that or lack of shape of that droplet. We're going to make sure we have a clean toothpick, and we're going to encourage the mixture again. Oh, look at that, what's happening along the border there. See all that wiggly stuff? That's really cool. And you do see some green area in here. Blue is still up here, but no really good area of yellow separated out, unlike this, which still has some yellow areas. Okay, so we have 4 distinct mixing events with our different solutions and blue water. Now when we get to this one, here's our option to do something, especially if there is a group of you together and you want to try to test someone's observation capabilities. We now have this set that corresponds to the 4 solutions that we had over here, but we have them coded so we can't tell which is which. So we're going to hopefully test water with one of these solutions and try to figure out what the unknown solution is. And we should know that by what we noticed when we did all the other ones. So I am going to use blue water up here again. 1, 2, 3, 4, 5. And let's say we pick C. What is C? Let's try down here. 1, 2, 3, 4, 5. Okay, you pick up something by just the way that droplet looks. And let's move this close again. Okay, look at what's going on at that boundary again. We see some yellow again, but it's disappearing quickly. And what does that remind you of? It's actually sitting right next to the alcohol and looks very, very similar to that. Let's try one more. But you get the idea. Scientists do this all the time. They do a lot of experiments with known materials so that when they come across an unknown and they know when they need to know what it is, they can check it against what they've already got and then identify an unknown. 1, 2, 3, 4, 5. Notice the shape of those droplets again, and we get ourselves a clean toothpick. Oh, and what does that remind you of? I think we saw that before. The 2 droplets were similar to begin with, and now we see this yellow rim around the joined droplets. So what do you think? Salt water, I think. So this is a nice, neat experiment to show you how different chemicals interact with water and then how they combine with solutions of pure water. Plus we get the added benefit of seeing the difference in the ways that the color changes when we do that. So if you have any questions, you can be happy to contact us. My email is reginamalcziewski@gmail.com. And you can also, we'll probably post this video to our Facebook page, Midland ACS Facebook, and we have a website, www.midlandacs.org, and you can also leave a message for us there. Thanks for joining us. Hope you learned something. See you next time.